All right, everyone, I'm going to go through this question from your MyMathLab homework. This is section 2.2, number 6. We had a few questions on the discussion board about how to go through this one, so let's just go through it together. In this question, you are asked which of the following statements are true, and all these statements are about subsets. So we need to remember first that a set A is a subset of a set B if and only if for all of the elements X in the set A, X is in the set B. So we need everything in A to be also in set B. So the first subset relationship we have to determine if it's true or false is 0 a subset of the empty set? Now, this first question is false because 0 itself is not a set. It's just a number. And this empty set is the set that has nothing inside of it. So these are not subsets of one another because 0 is not even a set to begin with. All right, if we move on to part B, we're asked, is 64 a subset of this set? So first we need to break down what this means. So what we have is the set of all X, where X is equal to 2 to the N, and N is in the natural numbers. So the natural numbers, just to remind you, are the set of all of our counting numbers starting with 1. So 1, 2, 3, 4, and so on up infinitely. So we can figure out what is in this set. Let's call this set A for now. So set A is the set of all X, where X is equal to 2 to the N in the natural numbers. So we can figure out a list of the numbers in A by starting with our natural number 1. So when N equals 1, X will be equal to 2 to the 1, which is just 2. When N equals 2, we'll have X equal to the 2, which is 4. When N equals 3, X will be equal to 2 cubed, which is 8. When N is 4, X will be equal to 2 to the 4th, which is 16. And so on. We can keep doing this forever and ever. So we can rewrite the list of all of these elements as 2, 4, 8, 16, and so on. So ... means just this pattern continues forever. So now that we've figured out what this set on the right-hand side of the statement is, what it looks like, we can ask ourselves, is 64 a subset of this set? Now, similarly to part A, this statement has to be false because 64 is not a set. It's just a number. So it's not possible for 64 to be a subset of another set. Now, what we could say, if we wanted to make this into a true statement, is we would ask, is the set with just 64 in it a subset of A? This would be true because I would eventually find, I think it's going to be N equals 6. We'll have X equal to 2 to the 6th power, which is 2 times 2 times 2 times 2 times 2 times 2, which is 4 times 4 times 4, is 16 times 4, which is equal to 64. So 64 will be an element of the set A. The set of just the element 64 is a subset of A, but 64 itself is not a subset of A. Okay, so let's look at these other two statements. All right, so when we look at part C, we need to notice again, we have the same thing going on here. 3005 is just a number. It's not a set. So it doesn't make any mathematical sense for this to be a subset relationship. So this is false. And then this last one, part D, is X a subset of this set here? And we have the same set. This is our set A from part B again. But again, X is not a set. X is just an element. So the subset relationship doesn't make sense here. All right, so this one should be all four false, mainly because the left-hand side of these relationships are all not sets. They're just numbers or perspective elements. So I hope that helps. You should first notice